You heard quite a lot from my colleagues. It's also great to hear something from our users. It's a great pleasure that I can welcome representatives of two of our customers here in the studio. Vojtech Skrob from Hitachi Energy Services. Hello.
Hello. Good afternoon, good evening to Western parts.
What do you do in Hitachi?
In Hitachi, I'm a steel engineer. That means I'm doing design and analysis of steel structures.
Awesome. Thanks a lot. Then we got Zoltan from Swanton Engineering. Hello.
Hi, how are you doing?
All good, thanks. What's your role in the organization?
I'm senior engineer, responsible usually with design management or leadership of the projects we have at Swanton Consulting, and I have specific roles related to IDEA StatiCa. I usually do in-house training and mentoring and internal presentations of connection design in general and IDEA StatiCa specifically.
All right, thank you very much. Viktor, how are you?
Hello, I'm fine. Thank you for being
also
here.
From Swanton, so what do you do?
Yes, I'm the Associate Director of Swanton Consulting, and I'm pretty much dealing with enhancing the workflow, incorporating advanced numerical methods within our daily design, and trying to incorporate and accelerate the delivery of the process.
To mix up this panel a little bit, we also have Ralph Ballinger, Product Engineer. Hello.
Hello, you're right.
So what is it that you do at IDEA StatiCa?
So I'm part of a much bigger team of product engineers, and together we help our customers. We talk to our customers daily, trying to understand their needs, their processes and workflows, and offer assistance where possible. But also we do a lot of other things in the background, support articles, blog posts, anything that helps our customers, basically.
Awesome. And it helped, or hopefully it helped for Swanton. So I'll ask Viktor to tell us a little bit more about how do you use IDEA StatiCa?
We are users since 2017, and that has been a great help. It has been providing us with ammunition to deal with some really difficult connections, sometimes go beyond codes and rules.
Perfect.
Go to stress and strain analysis.
And I will challenge you to show us a little bit more in visual, okay?
Fantastic.
Let's do it.
Hello, good afternoon again. We will be proceeding to the presentation of Swanton Consulting. I will be dealing pretty much with what we do, and then giving the speech to my colleague Zoltan to proceed with some more information regarding some of the projects and the utilization of IDEA StatiCa. So we like to identify ourselves as specialist engineers dealing with some complex projects, and we are practically specializing in construction methodology and direction sequence, and I will be elaborating on this a bit more later. We're also dealing with lots of testing and monitoring of existing structures, and we do provide training schemes for all the construction parts. That is including construction operators, but also engineers of all the disciplines, of course, who are on site. So what do we practically do? We deal with superstructures. We begin our process from the demolition part and going down, knocking down a building, up to reach the foundation level. And then we proceed to the next step, which is developing the superstructure and all the construction methodologies, sequences, and how we can be optimizing the whole process in terms of speed, cost, and efficiency, of course. We do operate in very, very confined urban spaces, since we are based in London, having some high-value adjacent properties, so we are specialized also in deep basements and ground movement assessments. But that means that we need to find some clever ways, let's say it, in order to provide proper retention schemes. And this is where IDEA StatiCa is using us quite a lot in the past and future, of course. Also, we are a diverse team with several backgrounds and different cultures, and we do share a love for historic buildings. So we are offering services that are partially incorporating heritage structures or parts of the structures like facades, and we're developing retaining, supporting scheme, but also the means and ways to incorporate them within the main new structure and the whole structural scheme, which is a quite challenging environment since the global deflections need to be extremely low to avoid any damage. But apart from us being engineers, we are also dealing with the construction and working for and with them. That means that we are participating in contractors' design elements. That means that we are having a high volume of joint detailing development within the company, and that has two wider aspects. One of these is providing some joints or details for large manufacturing industrial processes like proprietary schemes, but we are also designing joints of all the elements, steel, reinforced concrete, FRPs for strengthening, and these are bespoke, particularly for one single project, or repetitive, but still within one project. And this is a part that also we have been utilizing IDEA StatiCa significantly. Just a short history, we have been using IDEA StatiCa, as I mentioned before, since 2017, and we do have 4 licenses so far. We have a database from more than 2,000 IDEA StatiCa different connections, and we have been having apparently a vast number of connections. It was a nice story, us getting to know IDEA StatiCa, because that happened having a recommendation from National Technical University of Athens and Professor Vagias, who highly recommended IDEA StatiCa, and since his team in the university are using this, still they're using it actually. So that was the first touch with IDEA StatiCa. And now I will be passing the speech to my colleague Zoltan, who will be elaborating in all the details and some projects we have been undertaking so far. Thank you.
I will try to show you how we use IDEA StatiCa in the day-to-day engineering and design by the example of some of the more important projects we've worked on throughout these years. Starting with Battersea Power Station, which is a landmark London building, probably appeared in the common knowledge after its appearance on a Pink Floyd album cover in 1977, but also in various movies. This is probably the largest project happening in London right now. It's an 8 billion project. A lot of different things happening, new homes, office spaces, shopping centers, a new tube station. And we predominantly worked on the facade of the power station itself, where it was refurbished, and a lot of new steel members were connected to existing historical steel structures, which means that it's old types of sections, a lot of plated sections, riveted sections, and we needed to connect to these historical members, resulting in a lot of quirky connections with a lot of eccentricities, a lot of rivet checking and considerations for the historical nature of the structure. Another important project for us was 60 Curzon Street. It's a residential development in London. We did a lot of connections for permanent steelwork, temporary structures, tower crane grillages, but also precast reinforced concrete design. Some of the connections on the screen, it's a demonstration of a lot of heavy-duty connections with high forces, but also very intricate and non-typical designs. The bottom two are shear keys, basically cast into reinforced concrete with reinforced concrete rebar couplers and splices incorporated into the connection area, very heavy elements, where we had a great help from IDEA StatiCa in designing and assessing all these things. Next one, 1 to 5 Grosvenor Place. This is a project where we supported our mother company, Erith. It's a 8-story high superstructure and with 5 additional levels of basement. We designed a 27-meter long vehicle bridge with 2 loading gantries, various propping designs, structural strengthenings in the basement, incorporating a thrust block into a highly loaded propping area. And this is a project that we submitted for British Construction Industry Awards, and we got a high commendation for it. And just 2 examples from connections we designed in IDEA StatiCa for this project is, the top one is a strengthening of a plunge column and 2 gantry beams, and a highly loaded prop end connection where we utilized 2 bearing surfaces and a corner of a capping beam to reduce the shear loads in the anchors. And finally, 1 Sherwood Street, where you might recognize a certain London hallmark feature. It was a very complex and very constrained project with a very narrow space, and we needed to be considerate of the neighboring tenants, and there were live tenants on the footprint of the project. We did facade retention screens, we did a complex construction engineering and sequencing design here on this project, sheet pile design, party wall supports, and tower crane grillages on top of concrete cores at 7-8 stories high. The first example is exactly a tower crane holding down connection, and several bespoke connections we utilized in the project with extensions of proprietary RMD veilers and ceiling hangers, and just a couple of examples. There were hundreds of connections designed on this project. And now we move on to the workflow. How do we utilize IDEA StatiCa in our day-to-day practice? I would say probably it's not there yet. We'd like to optimize it further because usually how we start it is in IDEA StatiCa, and then everything is either modeled into Tekla structures, or we prepare sketches for external contractors and then they model it based on those sketches. But we also utilize the BIM link in cases where it's a lot more reasonable to model the connection in Tekla structures first and export it into IDEA StatiCa and check for load cases. There's an example on the screen of such a connection, and there were many other cases similar to this. Load matching for anchor design. So we are utilizing IDEA StatiCa's capabilities of flexible base plate design and flexible base plate checking, where we are accounting for prying forces and deformations of concrete and steel. And with the forces we obtain from IDEA StatiCa, we do a load matching design in, let's say, in Hilti Profis to check for the actual anchor capacities with all the edge distances, and sometimes we take it even further into verifying these connections with additional reinforcement. And finally, in some cases, this is the tower crane holding down connection from Sherwood Street, where we needed to look into more specifically in the stress distribution of the contact stresses from the crane base into the concrete element. So we utilized the stress layout from IDEA StatiCa to check in a 3D model where we had the whole grillage and the interaction and the concrete modeled, not to have a megapascal by megapascal resemblance, but just to check if the assumption is right and if the distribution and the behavior is as expected in both cases. And finally, what we would like from IDEA StatiCa, probably there's a lot of customers, I'm sure, who have their own agendas. We have our own as well. We would be very much utilizing a direct import of connections into Tekla structures from IDEA StatiCa, and it would particularly be useful for our external clients, where we could prepare the connection and just send the IDEA con file over to import. Also, the example on the screen is a surface load, a uniformly distributed load modeled or trying to model it. It's the shear key from Curzon Street. So we had a uniformly distributed load on the top plate, which we modeled with a series of members with an axial load to obtain a similar behavior. And finally, based on the Battersea example, but we came across on other projects, this problem is a bit more support in historic steelwork capabilities, checking particularly rivets. And when we have plated sections, sometimes we need to look into how the slip surfaces work and the shear flow is translated into rivet forces. And it would be something that would be probably a pretty good market value for us. Thank you for your time.
Thanks a lot for the presentation, Viktor and Zoltan. I see a hard question coming your way right away from the public. For what do you optimize connections? Viktor.
Well, the optimization has several aspects, actually. One of these is sustainability, but also its financial aspects and constructability, because as I mentioned, we do want to be creating something that's quite easy to install. And we always think of not the user, but the guys on site. It is extremely important to make it easier for them to work efficiently, but safe and in a correct manner.
Okay. Zoltan, your opinion about
Yeah,
optimizing connections
it's an
in
interesting one because we don't deal in mass-produced structures, so there's no economies on scale. A lot of cases we are dealing with bespoke connections, but there's also some cornerstones of optimization. Let's say we try to avoid full penetration welds. We try to avoid unutilized welds. For example, if you place your strength stiffener strategically, you are utilizing the weld to its capacity, so you don't have to increase it in a middle region, for example. It's designing it wisely what makes optimum connections for us.
Okay. And is time you spent on it, is it a factor?
Absolutely. Well, the production of connection designs in Swanton increased significantly since we started utilizing IDEA StatiCa. Obviously, there's a learning curve for every engineer to get into using it wisely. But even with this time, we are still in a good place.
Vojtech, hearing this, how do you optimize connections at Hitachi Energy?
Yes, generally we are optimizing within some standardized structures, which we use quite often. So that means our focus mostly is the engineering part of our company is to reduce the steel amount mostly. As Zoltan said, for sure there are these aspects of not only steel weight but also the costly, for example, penetration welds, as you mentioned. But because we are not such close to the manufacturer, we are not much informed about this. So mostly we are focused on the steel weight.
Got it. Ralph, your experience with optimizing connections?
I think there's several factors. I mean, we always used to talk about cost, but with such bespoke structures, cost becomes a non-argument, really. It's making the best use of engineers' time on these sorts of structures where optimization really comes into play. And we've talked about doing more connections in less time. We talk about doing the same amount of connections faster. But it's multiple ways that you can look at it, really. For me, with these sort of structures, it's got to be that time saving and knowing that you can count on a tool that is easy to use and gives you the good answers in a relatively short space of time.
Okay. You guys mentioned cooperation with the others. I see relevant stakeholders. That's intriguing. So how do you guys cooperate with relevant stakeholders on the project? Victor?
Well, the most important factor is communication. So early doors communication, informing them that...
And who is them?
Well, it depends on the project. Actually, it could be from a major contractor like a huge company, or leading up to the development portfolio, which are actually the investors. But usually this is happening via a proper presentation, identifying several solutions that we can, or several paths or routes that we can be following and going this way, presenting with pros and cons, and then subsequently leaving them to decide, but without forgetting the engineering principles. But again, at the end of the day, is always communication. And this is not one time, it's a whole project life cycle communication.
Okay. Zoltan, what are the stakeholders pushing you around the most?
Well, it's several things. There's a design price, obviously, and that's where the optimization of the engineering time comes in. There's the delivery time, because we are at the sharp end, so in a lot of cases we are designing for the steelwork contractor who are on tight deadlines, so making it work for them is very important. And obviously the constructability. It's very important to have a solution that is easy to build.
Okay. Vojtech, your experience, cooperation with other stakeholders on the project?
In our case, this is not much good, I would say, as our main stakeholders are our managers of the project within Hitachi. That means they are taking also questions or impacts from other parts and putting all together. And usually, in our case, this works this way, that we provide a model, provide some solution, and we have defined some, let's say, gate time or gate lines where we shall have prepared some model for some approval. And usually, as I will discuss later, in our case, the final product or the focus is not much on the steel parts of the final product. So usually we are quite free to do what we want. On the other side, surely we are providing our design to manufacturers who also have sometimes some doubts or some question why something is doing this way, because it's problematic for them to manufacture it. So within this feedback, we are getting the information. But honestly, in our case, there is no this really effective and direct communication.
Right. Yeah. I think the size of Hitachi helps a lot in pushing what you want to do in the projects. Very good. Ralph, your experience in how engineer, fabricator, how they come together on projects and the investors?
It's still very varied, and it really does depend on the stakeholders that are involved in the project, for sure. Some stakeholders are more, shall we say, educated in certain processes surrounding BIM, etc., than others, and it really does show. Going forward, I believe, hope that the next big advances that we'll see in the industry are around workflows and how we communicate with each other, not just at a technical level, but also trying to convey the the thought and processes behind the engineering solutions. And I love the fact that what Stanton's came up with initially was communication, which at the end of the day is what engineers are all about, communication.
Thank you. I see a question about our new features. Zoltan, so new application of IDEA StatiCa called Member. Are you aware of it and using it or not?
We did use the beam feature.
Okay.
We didn't use the member feature so far, but it's definitely something we want to trial, and also we are looking forward for the chatbot as well.
So lots of goodies.
Yes.
Recently released. Okay, let's now hear from Hitachi Energy and how they handle projects around the world.
So welcome to my presentation, which is using IDEA StatiCa within Hitachi Energy. Hitachi Energy, Czech Republic, that's the company where we are working. I guess that if you hear Hitachi, probably most of you will think about some heavy machinery, about some electrical equipment maybe, or electrical tool, maybe also about some electronics. In fact, the portfolio is much wider, and Hitachi Energy in our production unit is focused on gas-insulated high-voltage switchgears. It's quite complicated name. I guess that most of you knows probably what does high-voltage switchgear means. Actually, in terms of transmission of electric power, it's some nodal point in the transmission network. That means this node works for some transformation of the voltage level, for monitoring of electric characteristics, and also for other purposes. So if that's quite clear, and if you guess what does gas insulated means, in fact, it means that the energy is enclosed in some pressurized tube. That means from the structural point of view, our structures looks like some pipeline, or actually works like some pipeline, the same as oil pipeline or heating. So that's that way. If you take a look on the pictures, or maybe the question, why does electrician needs software for structural engineering, for structural analysis, I've already said that we are still engineering. That means our part is focused on the evaluation of the forces on the pipelines, and also design and analysis of the steel supporting structures, and also some service platforms that works for better reachability to some of those devices. As you can see in the picture, our switchgears can be located indoor or outdoor, and generally our projects are all over the world. That means the loading conditions and generally environments quite differs from some hot desert areas in Arabic countries up to some cold Siberian landsides, or from urban side up to sea offshore platforms. There is a typical picture that all of you knows, that shows maybe just you would need to replace some of the names of the softwares, but that shows the relationships between within our workflow. So you can see that for the CAD, we are using Tekla structures. For the global analysis, we are using SCIA Engineer, and definitely for some extensive analysis, we are using other softwares. That means one of those is IDEA StatiCa. But what I would like to highlight and show you or pay attention for it is the type of that arrows. You can see that some of them are full or continuous, some of them are dotted. That means where there is a full arrow, that means we are fully using the PIM links. In case of dashed or dotted arrows, usually we provide just some manual transfer of the information or some copy-paste actions. I guess some of you may think why we don't use direct link from SCIA to IDEA StatiCa. In fact, in some projects we do it this way, but mostly we don't. Actually, if we do it this way, then it means that we have two IDEA StatiCa models, one with the correct geometry, second with the correct forces, and afterwards we need to merge these two models together. So as I said, mostly it looks just like we take the complex connection or complex solution of the connection from Tekla structures and add some of the forces manually. There are few examples of some models provided. I will start from the left upper corner. There is some lifting lock. I will discuss this later on following slides. Then there is hinge detail or some plastic hinge detail, so-called dog bone, which helped us to reduce forces in the anchors or in the bolts underneath. And you can see also some results or pictures from standardized or analysis of optimization of some standardized structures and standardized connections. One of those is eccentrically welded cassette plate to hollow square section. Second is some anchoring adapter, which helped us to prove the tolerances within foundations and pre-embedded anchors. Then there is some detail of welding of a skid frame to a steel deck floor, and also some detail or some model of preliminary analysis of standardized apparatus, which is connecting the pressurized tubes, that means our electrical equipment that we are supporting, with our structure. So now few words or few slides to the detail of the lifting eye. That was the request that there will be some assembly unit which will be assembled in the factory. That means there will be some skid. On this steel skid will be placed the electrical equipment, the part of the GIS, of the gas insulated switchgear, also with some monitoring boxes. Surely there will be our structure supporting that electrical equipment, and also some type of or part of service platform. And this all together will be, after the assembly, it will be lifted to some track, driven to harbor, lifted again to the position, correct position within an offshore platform. And then this offshore platform will be sailed to the final destination. So we had several disassembly units analyzed within the global analytical model. We found the highest forces within the ropes or within the slings, and then we needed to design the lifting eye for this purpose. So the requirement was to provide lifting according to that Norske Verita code, which quite good cover the assessment of some bearing and tear out stresses in the pedi, and also other things. So you can see there is also some standardized shackle which was not analyzed, but we afterwards we modeled this to provide the correct distribution of the stresses. So we analyzed this, it was okay, but we were not sure regarding the stresses under the lifting lug itself. That means the connection between the lifting plate or lifting lug plate and between the skid frame. So that's why it was time for IDEA StatiCa to model it or transfer it from Tekla structures to the model to IDEA StatiCa. Actually, in this time, we were not sure, or it was not clarified, what type of analysis we are supposed to use. For sure, for us, it would be easier or better regarding the total weight and regarding the stresses to use load resistance factor design. But as we were not sure, we provided both analyses. Anyway, both of them were or had quite big plastified areas, and actually in case of working stress design, the plastification or generally the inelastic analysis is not required or not used. So that's why, or not only because of this, but also because we wanted to avoid this permanent deformation just in the beginning before we are holding or handing the final product to our final customer. We wanted to improve this connection. So the first idea was to replace the original part of the skid beam with the same size profile but with bigger wall thickness. That means the original profile was 250 millimeter square profile with 10 millimeter thickness, and we extended or replaced the affected part with the same profile, 60 millimeter thickness. You can see that the results are much better. But anyway, after discussion with the manufacturer, as we already discussed, we were said that this is not a much good solution regarding keeping of some tolerances regarding straightness of the beam. So that's why we provided several different solutions. The final one looked this way, that we cut it only the upper part of the square profile. We replaced it with a plate of a bigger thickness. Because we opened this profile, that way we were also able to provide some inner stiffeners, which definitely helped as well. And after the calculation and analysis, we could see that the results were even better. That means we were satisfied with this because there is nearly no plastic area under the lifting lug. So that was okay, and just in this time it's prepared for the manufacturing drawings and for the manufacturing itself. So that's all from my presentation. I thank you for your attention, and I especially would like to thank to IDEA StatiCa for its application, which definitely helps us to prove some of these connections, those connections that in past we needed to send to some external offices to provide some complex FEM analysis, or in other way we needed to provide some simplified handmade calculations, which is definitely not the best way how to deal with these problems. So thank you.
Thanks to Vojtech for the presentation. Interesting area of before IDEA StatiCa. Viktor, how did you do steel connections before IDEA StatiCa?
Well, with the basic engineering principles, so we have been following Eurocode 3, Part 1.8, and doing some hand calculations, which later on we developed some templates standardizing types of connections with spreadsheets or MathCAD. And now, that's why we're here, actually, using IDEA.
Zoltan, I guess you're more hands-on, right, on those MathCADs and...
Yes, well, it's pretty similar. There are several software companies who provide CBFM analysis types, which is basically an automatic method to translate the Eurocode calculations into results. Consteel. I was using Consteel before the CS joint part of Consteel for hand calculations. A puzzle of Eurocode methods. If there was anything beyond this type of design.
Ralph, your experience, connection design before or without IDEA StatiCa?
So before, blimey. Yeah, you're talking hand calculations, you're talking Excel spreadsheets, you're talking investment in the development of those spreadsheets as well. And to the ultimate extreme, you're talking about complicated FEA solutions using things like Nastran, which take an expert a long length of time and a hellishly long in comparison time to analyse to get your results out. And we know that time is a big constraint factor in projects nowadays. So yeah, it's doesn't bear thinking about.
All right. And there's a question about the handover. Which is the best way to convert connection design details done in IDEA StatiCa to connection detailer or draftsman in preparing shop fabrication drawings? Vojtech, what do you think?
So generally, what is the best way? Actually, I have never thought about it, because in our cases, we are providing also the manufacturing drawings. That means the link is nearly direct. Sometimes it's provided by the same engineer, sometimes it's just on some discussion, but just eyes to eyes. So in our case, this is definitely not an issue, but generally, I guess that there should be, I guess that the best platform is to work with some BIM solutions and provide the transfer of the information within those applications.
Okay. So let's go into more complex scenario. You guys don't do detailing, right?
We do. There's several types of projects, but we have an in-house detailing and technician team who are modeling. And
so how do you deliver information to them?
Usually with the IDEA StatiCa viewer.
Okay.
So we have the IDEA StatiCa files, they open it in the viewer, and obviously there's some additional information sometimes to be given, because you have the plates separately and you don't exactly have the relationship between profile and
so you
plate.
actually generate IDEA.con files, you send it to the detailer, and they go to our website, launch the free viewer application, they can open the connection, download the DVG, right?
Sometimes, yes, yeah.
And model that into Tekla structures most of the times, right?
Yes.
Or there's the other option when we start with the Tekla structures and then use the BIM link to export it to IDEA.con, and then there's the direct link.
Right. Ralph, hearing this, is that state of the art?
It's definitely getting there. It's a much better way than I used to transfer data when I was in engineering consultancy, which was sketches on a piece of paper done with a pencil. So things have come a long way. And I do like the idea of not repeating data, but to reuse and repurpose the data. So anything that reduces that amount of reuse, I'm all for. We used to talk about a paperless office. We're still a long way off that, but we're definitely producing less paper, which is a good thing. But I think if we can maintain an electronic distribution that we can track and trace, and we have that accountability, the viewer option is a very good way of communicating.
Yes, we have been using it.
It's great to hear. It's also one of our simplest applications we've ever developed. There's no science to it, no sophisticated solver, but it helps to save a lot of time and enable the BIM workflows. I see a question about the future, so maybe we can try to say, from your point of view, what's the most important thing in the future about the workflows, what could or should improve? Viktor?
Well, since we are dealing with this quite heavily, we do foster and we would be proposing sort of a parametric development, meaning dealing with parametric analysis, not only for the structures, but also for the connections, which is significantly important in optimization, but also in presentations and explaining the concepts and the approach to the stakeholder or the client.
I like it. Zoltan, your idea?
Yes, parametric definitely, and usually improving the communication between various types of software. So it's the directional links. Do they communicate? Can you transfer information from one to the other? That's probably the first step. And then is there a bidirectional communication between the two? Can they react to the changes in the other one? So that's definitely something that is the future.
All right. Vojtech, anything you would add to this? Future wishes?
Actually, the same. As I already mentioned in the presentation, for the, let's say, short time, not much long time run, I would see the effective process to work not only, or to have BIM link not only between two softwares, but between three softwares. That means IDEA StatiCa, CAD software, and analytical software.
Analytical software. Okay, good. Guys,
and also, I would like to add something. Yes, it's important that we have workflows and tools and everything, but ultimately these are tools. So it's almost like we need to know what the end result is before we start running the numbers. So developing the engineers is also extremely important.
Basic principles of engineering.
Yes. I think that's a great summary of this blog, great summary of the user experience with IDEA StatiCa. Then concludes the blog number 2, and I thank you guys a lot.
Thank you for having us.
Thank you so much.
Thank you.
Keep up.